Once again, you are welcome to yet another lesson of Physics Paper 2, A-Level teacher course of Back Science Education Consultants. You can go to our YouTube channel, BASC Science Education Consultants, and you subscribe to our channel and you watch many of these videos. You can also check teacher course also on YouTube. You'll also find some other interesting things there. You are going to like it. They are educational. They are really inspiring. Our contact is there. You can contact us in case of any help because we provide many services not limited to these online lessons. Then the guidance and counseling, which is important, especially in these days. You have a challenge, your colleague has a challenge, direct him or her to us. Even if he's a married person, direct them to us. Even if the challenge can be educational, can be social, can be financial, you just direct them to us. We are going to discuss with them. We are going to help them get to where they actually feel they should be. But for now, we are moving with Physics Paper 2. We have looked at several things ever since we started. The most recent, we are looking at the electric field intensity. And then we are saying that this is the force on one positive Coulomb charge, which is placed at any point in an electrostatic field. Okay? We looked at, of course, we had looked at the force before that. And now we are still moving. Another term, potential, electric potential. The potential of the charges, which makes it electric potential. We know the word potential, okay? It has much to do with maybe the capacity. Remember one of our friends, the musicians, had to sing, Halina potential asobola. So that's the meaning. You have the potential, you have the capacity, okay? This is what you are looking at in a science way, in a mathematics way. And you're going to see what is now this potential in electrostatics. So what is electric potential at any point? Because whatever we are doing it in a field. So if this is a field, this is our electric field. So what is a electric potential at a certain point? Let me call that point A. What is that potential? This is a field. So we have a certain charge of 1 coulomb, actually positive. So if the work, I do some work against this field, okay? I do work against this field to bring this charge up to this point. That work that I have done is the potential at point A. Meaning the potential at point A differs from the potential maybe at point B, at point K. It will be different. It depends on the position. And it is the work done to move one positive Coulomb charge from this to that one. I can compare it with a transport. Somebody is traveling from Arua to Kampala. How much does that person pay? Let's say he pays 60,000 as a bus fare. That money paid for one person to be brought from Arua to Kampala, I would say that is the potential of the money in terms of transportation. If you don't have that money, you may reach somewhere on the way they say, for you, you are stopping here because what you paid doesn't go beyond this potential, the work done to move this from here to there. We are saying 1. You can't say that because from Arua to Kampala is 60, then you say, but I have my other brother or my other sister. Since it is 60, then it's that. No, there are 2. You multiply. We shall find that one somewhere. Okay? So for now, let's first go with that. So what is electric potential? I am not going to write it, but we have said that this is the work done in moving one positive Coulomb charge from infinity to a point against electric field. That is the electric potential. The work done in moving one positive coulomb of charge from infinity to a point against electric field. From infinity, from outside the field. That's what it means ideally. From outside the field. Because the concept of infinity is also another complicated concept which made some mathematicians and scientists go into mental asylum that I would not want you to go into. But for now, just know that infinity is where, for this case, when you're talking about electric field, infinity is where you can't reach in this term. So meaning infinity is outside the field. Okay? The infinity of Uganda is outside Uganda. Right? Just get it like that. Okay? So we say it is the work done in moving one positive coulomb of charge from infinity to a point against electric field. Unlike electric force and electric field intensity, which are vector quantities, this electric potential is a scalar quantity. This one is a scalar quantity. Just have to know that. And meaning when we are doing the calculations, we shall not consider the directions. We shall not consider the calculation of angles. We shall, when we are talking about algebraic sum, we shall just add. But it means if a charge is maybe involved somewhere and it has a negative, that negative has to be included in the calculation. Okay? That is very, very important. Can we look at expression for electric potential? Yes, you can continue calling it V because we are using that. So, which expression can we use and we are able to get the electric potential? We are considering a one coulomb charge, which is x meters away from a positive charge Q. So, there is a positive charge Q here. We are saying there is plus 1 coulomb, and they are saying the two are a distance x meters apart. Okay, the distance x meters apart, and we are saying we want to move this one coulomb charge from this point to some other point. Maybe this is point A, so we can move it to point B, which is a distance, just a small distance, delta x. We want this to move it through that small distance, delta x. We don't want to affect, of course, the electric field of that charge Q, due to that charge Q. So we are going to perform a calculation. Okay, we are going to perform, and we are going to see that the small work done to move this one from here to here, I can represent it as dW, the small work done. From O level, we studied that work done is the product of force and distance, and therefore we use the same, is force times distance, which is our delta x. Okay, but this work is done against the electric force, electric field. So this work done is negated, is given a negative sign because it is against the electric field. Therefore, we shall have the small work done equivalent to negative F delta x. But we know this force due to this charge, which is Q. Of course, this is 1, okay? Out of 4 pi epsilon, then the distance between them is x squared. I am reading it as epsilon general for any medium. Okay? that is the small work done. But then we want work done to go to any point, anywhere. We want to generalize to move this one to any point. So maybe any point which is maybe at this point a distance from Q. So how do we do? These are small things. Okay? There is some dx here. Okay? These are small things. So in order to get a very big thing, we would be adding the small work done. The small work, the small work, and the small work. But then in order to do that, we integrate. So the work done will be the integral. We said from infinity then to r. Then this is q out of 4 pi epsilon x squared with respect to x. Q is constant, 4 pi epsilon is constant. So therefore we shall have work done equals q out of 4 pi epsilon integral from negative infinity to r of 1 out of x squared dx. This is yet to integrate. Can just put this one up and then the 2 gets a negative power. So this is q out of 4 pi epsilon, the integral of x power negative 2 from negative infinity to r, which becomes q out of 4 pi epsilon. So when you integrate this one, increase the power by 1, it becomes x power negative 1. Then divide by the new power. The new power is negative 1. So therefore we shall have a negative of then x power negative 1 is same as negative 1 over x from negative infinity to r. However, we had some negative on this negative. Don't have to forget it. So we still have it. So when we continue, we substituting, shall have q out of 4 pi epsilon. Substitute this one here, comes 1 over r, then minus, substitute this one, negative 1 out of infinity. Okay? And therefore, our work done will be equal to, of course, when you substitute 1 over infinity, you get a 0. So you remain with this and this negative and this. They will cancel out, and we shall have q out of 4 pi epsilon naught. The potential is this one. Okay? The work done. This work is to move one positive quantum charge from this point, which is outside the field, to a certain point at a distance r from the charge. Okay? And by definition, I'll say that that work done is termed as the potential. Therefore, potential or the electric potential is q out of 4 pi epsilon naught. This is a very important statement. This is a very important statement. Remember, so far this is the third one. We began with, again to write it here, just to remind you, we began with the electric force, which was Q1, Q2 out of 4 pi epsilon r squared. Then we got E, which is one of the charges out of 4 pi epsilon r squared. Now we are finally getting potential, which is Q, maybe Q1 out of 4 pi epsilon r. You can see there is a slight difference. This and this, only one Q is positive 1. Therefore, we shall remain with this. Okay? Then from electric field intensity to potential, you see here we have R squared, but here we have R. That's the difference. And then we are saying these two are vector quantities, but you are saying that this one is a scalar quantity, meaning that also the way we shall be handling the calculations will be a bit different. Electric potential, we said, is the work done while moving one positive Coulomb charge from very far to a point against electrostatic force. We said it is a scalar quantity. We said in order to derive it, you just get one positive Coulomb charge, you get the small work done to move it to a certain point, maybe B through distance delta x, which is found to be negative F delta x. But the force we know is Q out of 4 pi epsilon x squared, because the distance of separation is x. Okay? And the work done is the integral from infinity to that point r. The integral from infinity to that point r, which we do it very well because this Q and these ones are constants. You put them outside, you integrate this one, you finally get this. When you substitute in the limits, the infinity and r, you finally get this one. That's the work done. But we are saying by definition that work done to move one positive Coulomb charge, because this is what we have done, okay, is the potential. Therefore, we finally have the expression for the potential. That is it. That's the beauty of science. Very nice. Don't forget to subscribe to our YouTube channel. And this lesson would be incomplete if it has no this other following lesson. That's very true. So, after studying this, the best option is follow the next lesson. And actually our lessons are organized in a way, when you go on YouTube, just check in the playlist. So when you check, you just check in the playlist. We have made our playlist public. So when you check in the playlist, you are able to get A-level physics paper 2. Instead of trying to scroll and get all the videos from the column, just check the playlist, then you get the playlist for physics paper 2 A-level. It will be simple for you. Once again, I'm Teacher Course of Back Science Education Consultants. My simple advice to you is, we are still in the struggle, and it's not yet about to be over. But those who persevere at the end are the ones who are going to be saved. In the academic language, to be saved is actually to excel. Okay? So, watch out for the next lesson. It is actually there already. It is there already. Don't wait for it. It is there already. After this, just click for the next lesson and you will surely watch, and I know you are going to get a lot. In case where you have a challenge, you have a question, you have a concern, just get us on our numbers 0788-205343. Can inbox us on WhatsApp, and more of the information is on our YouTube channel, BAC. Please subscribe there. Don't go without liking our videos. Don't go without sharing so that others can also benefit. Thank you for attending this lesson. May God bless you. May you have great time there.